Suppose the government decided to pay off the $19 trillion debt with a one-time charge distributed equally among the 200 million person civilian workforce. How much would each worker be charged? This is simply a division problem. You're going to take the number 19 trillion, and we'll go ahead and write that out. Once we write out 19 trillion, we're going to divide that by 200 million. And the textbook says it would be a good idea to use scientific notation in this case to make the problem easier. I don't necessarily agree with that one, simply because I can divide through by powers of 10 without having to actually write it all out, but then I will show that as the second phase of this particular example. So let's go ahead and talk about converting into scientific notation. Now, when we convert into scientific notation, we're going to move the decimal point that is inherent in every single integer that's out there. And we're going to move that decimal place either to the right or to the left so that we can end up with a number that is between 1 and 10. In this case, we're going to take this red decimal point and move it to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times so that I can end up with a number that is between 1 and 10, and that number would be 1.9. And now I'm going to multiply that by, so 1.9, as I said, times 10 to the 13th power. And then we're going to divide that by 2 million in scientific notation. Now, we're going to do the same thing. We're going to start here. We're going to move the decimal point to the left 1, 2, 3, 4, 5, 6, 7, 8 places to get 2. So now I have 2 times 10 to the 8th. And as I said, this is simply a division problem. So we can rewrite it as this, and then what we're going to do is we're going to split it up. And once I do that, and let me just slide this over to the left a little, I'm going to rewrite this so it looks just like this. I'm going to have 1.9 divided by 2 times 10 to the 13th power over 10 to the 8th power. Now, 1.9 divided by 2 is going to be 0.95 times, and this 10 to the 13th divided by 10 to the 8th, we're going to use the property of exponents and end up with 10 to the 13 minus 8 power. So I end up with 0.95 times 10 to the 5th power. Now, the problem with this is this 0.95 is not going to be in proper scientific notation, and I must move the decimal point to the right 1 unit. If I move it to the right 1 unit, that means that I'm going to subtract an exponent from the 5. And I'm going to end up with 9.5 times 10 to the 4th power. And as I look at this particular problem, 9.5 times 10 to the 4th power, that means that I'm going to move the decimal point to the right 4 places to write it in standard notation. And I end up with 95,000, and that's going to be my answer. Now, as I said, there's another way of looking at this. If I'm going to take this problem and I'm going to rewrite it again as 19 trillion, and I'm going to divide that by the 200 million, I can look at this and say, you know what? I'm just going to go ahead and divide through by powers of 10. Notice that there's 3 zeros to the right of this comma, likewise here. I'm going to do the same thing here. And then I'm going to simply divide the remaining 2 zeros here into 2 zeros up here. And I'm going to be left with this particular fraction. I'm going to have, oops, 19 followed by 4 zeros, which is going to be 190,000, divided by 2. And if I divide that out, I end up with the exact same answer that I got using scientific notation. And that's going to be the answer to the problem. And you'll notice that in MyMathLab, it says type an integer or a decimal. Do not include the dollar symbol in your answer. So in the answer field, I would simply type in 95,000. I don't necessarily have to put the comma in MyMathLab, but I can if I want to. Therefore, if the government decided to pay off the $19 trillion debt with a one-time charge distributed equally among the 200 million person civilian workforce, each worker would be charged $95,000.